Hey guys, welcome to third grade math, back with Miss Betby's, and we've got some really fun things planned. So this is one of the favorite units I feel like with some of the third graders, and so I think you're going to really like it. So we have the challenge of trying to teach you this from afar, which can be difficult, okay? And so those things that we're going to be focusing on this week are called mass and volume. Liquid volume is the one that we're focusing on, okay? And sometimes you hear it called capacity. And so we'll kind of get into that a little bit more as we get going and what that means and everything like that. But we've got a lot of things to look at today, and my goal for us today is to really teach you, what do those terms mean? What is mass? What is volume? And really just kind of looking at some different ways to measure those things. We measure in units, and we're going to be looking at metric units today, and we are going to learn how to measure. And then on Thursday, my plan is to do a little more fun, engaging practice with it once we know what it is. So I'm excited to get to Thursday, but we've got to do this other stuff first. But I know you're going to enjoy it. It's really, interactive and fun, so I think that you'll like it. Okay, so let's get started. Well, the first thing we have to do is we need to figure out, what do these words mean that I keep telling you about? What is mass? What is volume? Okay, so let's look at that. So mass, okay, when we're trying to find what mass is how much matter is in an object, okay? Well, then I'm sure you're asking yourself, well, how do we find that? How can we find how much matter is in an object? Okay, because we can't always see it. Well, one way that we can do it is by finding its weight, okay? So we're going to look at that and look at what tool that we would use to find the weight of something, okay? So before we get started, I want to talk to you about those units of measurement. If we weigh something, you guys are used to hearing things being weighed in pounds and ounces. That's what we use here with customary measurement in the United States. But we're going to look at some new metric terms that I'm sure that you've heard before, but we need to really make sure we understand how to differentiate between the units so we can do some more fun activities with them, okay? So some units of measurement for mass that we're going to be talking about are grams and kilograms. All right, well, let's talk about those. What is a gram and what is a kilogram? What does that look like? What does it feel like, okay? So a gram, picture like a large size paper clip about this big, not the small one, the larger size. Okay, picture holding one of those. Is that very heavy? No, it's actually really, really light, isn't it? Yes, okay, well, that is about equivalent to 1 gram. Okay, so is 1 gram or a gram very heavy? No, it's pretty lightweight, and I actually have a weight, and it's so small and so thin because it's very lightweight, okay? So that's a gram, all right? And then a kilogram is, I want you to now picture holding like your textbook, your math textbook from school, your little workbook that you have, or maybe your reading textbook if you use those. Picture holding that. Now, how does that feel? Is that lighter or heavier than the gram? Okay, it's heavier, right? It's significantly heavier. So that is equivalent to about 1 kilogram, okay? Well, 1 kilogram is equivalent, it's equal to 1,000 grams. So when I get 1,000 of these, then I have 1 kilogram, okay? So that tells you how lightweight 1 gram is to 1 kilogram, right? Okay, so keep that in mind, all right? Now, what are some tools that we would use to measure the weight of something? What do you measure your weight with? A scale, right? Okay, so there's different types of scales, balances, okay? So this is the tool that we will be using a little bit today, more so on Thursday, okay? And so we are going to really get into measuring some things, but this is the tool that we would use to be able to find the mass of something, okay? You guys are used to seeing like a digital scale that tells you the answer. We're going to kind of just be comparing the weights of things and looking and using some different weights to find out how much things weigh. That's what we're going to be doing more of on Thursday, okay? So now let's think for just a minute. I have some pictures, and I want to see if you understand. Before we move on, we've got to see if we understand the difference between a gram and a kilogram. Okay, so I have some pictures here, and I'm going to hold them up. Okay, what is this a picture of? Okay, a whistle, right? Do you think a whistle would be closer, or how would we measure it? Let's think about this. We know it's heavier than 1 gram, right? But would we measure this in grams or in kilograms? So think about that. Our lighter weight items will be measured in grams, and our heavier items will be measured in kilograms. So what do you think we would use to measure a whistle? Grams or kilograms for our unit? Yes, if you said gram, then you are correct. So we have a gram dunk is what we're calling it today. Okay, so this we would measure in grams. All right, let's look at another one. All right, what about a pineapple? Think about, you have to really visualize right now because we don't have all of these things. I wish we did. And if you were in my classroom, I'd be handing you things left and right. But I can't do that through the TV. So I've got to really get you to visualize this. Okay, picture holding a pineapple. Do you think that would feel more like holding a textbook or more like holding a paper clip? Yeah, more like a textbook, right? Okay, it's pretty heavy. Is it really, really heavy? No, but it is a little heavier. So we're going to put this on the kilogram side. Does everybody see that? All right, let's look at another one. Look at this little bug. It might be a lightning bug because I see some little stuff coming out of its tail to show me that. Okay, so we have a little bug. Do you think that we are going to measure this bug in grams or in kilograms? Yeah, it's a little bug, so probably grams, right? So we have another gram dunk. All right, so there's that one. Okay, you ready for another one? Ooh, I like this one. What about a hammer? Picture holding a hammer, a real hammer. Okay, not a play hammer, a real one. And if we hold a real hammer in our hand, do you think that's more the weight of like a textbook in kilograms, or do you think it's more like a paper clip? It's heavier, right? So we need to go with kilograms. All right, let's look at another one. What about this little alligator or crocodile right here? Do you think that this would be measured in grams or kilograms? Which one? Yeah, it's heavier, right? Now, it depends obviously on like if it's a baby or not. However, we would still, even if it was a baby, we would probably measure that in kilograms. Very good. All right, what about this one? A card, just one card, not the whole deck, just one card. What do you think we would measure that in? Picture holding that. That's very lightweight, isn't it? So we would use grams. Okay, good job. All right, we're going to do one more. What about this little lantern? Do you think that we would measure a lantern that shows light? Now, this one has like a little fire burning inside of it, but you probably see one with just a bulb. Do you think we would measure that in grams or kilograms? Okay, yes, probably kilograms. It's probably not real heavy, but it kind of depends. It depends on what it's made out of, plastic, metal, okay? We're going to do one more so we can have an equal amount on both sides. What about a single photograph? This is a photograph of children, okay? Do you think that this would be measured in grams or kilograms? We have another gram dunk, right? All right, so let's put it up there. Okay, so I think that we're getting better with understanding the difference between grams and kilograms. How do you feel about it? Think about that, okay? And if you are still struggling, think about what we've been talking about here, okay? 1,000 grams equal 1 kilogram. So your kilogram is your heavier weight and your gram is your lighter weight. So just try to practice and remember that so that when we meet back on Thursday, we can really do some fun experimenting together, okay? We're going to be some scientists on Thursday and really focus on that, all right? So now, if we wanted to use this tool, I'm just going to very basically show you how we would use this scale, okay? So the first thing that you want to do with a scale like this is make sure that it's equally balanced, okay? I just have little dishes on the side that will hold things, okay? This kind of scale is not going to be great for something really, really, really heavy. We could do the measurement of like an orange or an apple, which we'll look at on Thursday. And then, so what we want to do is, in order to figure out how much something weighs on this, we would take the item and put it on one side. It doesn't matter which side. And then on the other side, we would use these little weights, okay? These weights have value. They have a weight to them. Like this one is 50 grams. Okay, even 50 grams is still pretty lightweight. And I have a lot more. This is 1,000 grams. So this would be equivalent to what, everybody? The kilogram. Okay, so this is pretty heavy. So I could put this on one side, and then I could start using these weights or these, I have all of these, and start putting them in on the other side to try to get it to be equivalent. Now this is going to take a lot, so Miss Beckbees might take this one out, and let's put, right here I have 3 of these 10 grams. What's the value of 3 groups of 10, everybody? 30, 10, 20, 30, so that's 30 grams. Well, let's see. Here is a 20 gram weight. Is 30 greater or less than 20? It's greater, so 30 grams is greater than 20 grams. Do you see how this side's going down more than this side? It should be, because on a scale like this, your heavier item is going to go down while your lighter weight item goes up. Does everybody see that? Okay, so I'm going to kind of stop there with that today. We're going to hit on this a lot more Thursday, I promise, because I know that y'all love to do this kind of stuff and see how that works and then actually be able to do it, which I wish I could do that more with you. Now, the next thing that we're going to do is we're going to move away from mass for a minute, and we're going to move to something called volume. So as you get older in 4th and 5th grade, you are going to be looking a lot at volume, okay? So you need to understand what volume is. In 3rd grade, we only look at liquid volume, okay, which is a little bit different than the volume within a solid object, okay? Now, we are referring to it right up here as capacity, okay? They mean similar things, pretty much the same thing, and it's the amount that something can hold, okay? And a lot of times people use capacity more with like liquid volume, but it is still finding the volume. So if we want to find the volume of something, we want to know how much can it hold, okay? So think about like a water balloon. Who likes to play with water balloons? Okay, think about how much a balloon can hold. We don't know, we've never actually measured it, but you know if you get too much, it can explode, right? So you have to think about those things, and you have to think about how much things hold. Now, the more liquid in something, how does that feel mass-wise? Feels heavier, right? And the less you have, the lighter it is. Now, let's talk about these. The units of measure are different for volume than they are for mass, okay? So here, the units for volume are milliliter and liter that we're focusing on. These are not the only ones. These are just the ones that we're focusing on, okay? So a milliliter is equivalent to about 20 droplets of water. So picture just taking a dropper and dropping 20 droplets of water. Is that very much? Not really. So milliliters is going to be a smaller amount. Okay, and then a liter is about the size of a jug, okay? So picture a jug, and 1,000 milliliters is equivalent to 1 liter, just like 1,000 grams were equivalent to 1 kilogram, right? Okay, so it's kind of easy to remember they're both 1,000 of the smaller unit to reach the larger unit. So that'll help you to remember that, okay? So a liter is 1,000 milliliters. Picture like a pitcher of lemonade, right? That's pretty easy to picture, okay? So some tools that we might use for finding volume of a liquid would be a cylinder, a graduated cylinder, okay? Kind of like these right here. And then also a beaker, and then an eyedropper if you're doing very, very small amounts, those milliliters. Does everybody see that? Okay, so we're going to look at that, okay? So one of the biggest misconceptions, and a misconception is like a misunderstanding. For a child your age, a lot of you think that whatever the larger container is has more in it. Who thinks that? I know a lot of you do, okay? Well, that's not necessarily true, okay? It depends on how how big your container is or how small your container is. If it's a smaller container, it might look like it has more than if you have the exact same amount in a larger container. So that's what we're going to look at here. So I have a bowl of water, okay, and I have two size containers here, okay, and we are going to measure in milliliters. So it goes up by milliliters. Does everybody see that? Okay, and so remember that 1 milliliter was like 20 drops of water, okay, and 1,000 milliliters is equal to 1 liter, all right? So this has 1,000 milliliters. So this, if it is full to this line right here, and you want to look closely when we're measuring volume, you're going to have to look at these lines and really be able to see. So when I put some water in these in a minute, I'm going to show you that, and I'm going to color the water to help you see it easier as well. Okay, so this one goes to 1,000 milliliters, which we know is equivalent to 1 liter, and then this one goes to 500 milliliters. Let's think about our knowledge of numbers. 500 plus another 500 is how much, everybody? 1,000. So this is double the size of this. But I'm confused because they look like they're the same height. But look at the shape. One is wider than the other, right? Okay, so we're going to put 500 milliliters in both of these, and we're going to see if that looks the same. Are you ready? Okay, so I'm going to fill this up by dipping it in here. Okay, let me see. All right, we're just shy of that line. So dip a little bit. Oh, perfect, perfect. Okay, so to help you be able to see this a little bit better, oh, looks like I already added something. I don't know. Some green. Oh, goodness. Okay, use my finger. It's kind of fun to watch it and make a little mixture. Oh, as I'm spilling it everywhere. All right, so I'm just a little shy of 500 because Miss Betby's was having a little too much fun stirring. Okay, so there is 500 milliliters in this container. All right, now let's put 500 milliliters in this container and let's see if they look the same or if they look different. Okay, so this is the line for the 500 milliliters, okay. Ooh, that's fun to watch, isn't it? Red on this one. We've got some Christmas colors going on here. All right, so both of these have 500 milliliters in them, but look at them. Do they look the same? No, they don't. This one looks like it has more in it, doesn't it, than this one. But what did we talk about before? We talked about how this container was it was a little bit skinnier, right? The height was the same, but it was not as wide. This one was much wider, okay? It can hold double the amount of this. Does this look like it's halfway full, this container? It should, because we just talked about how half of 1,000 is 500, and we filled it up to 500 milliliters. So this should be half. This would also be, we could call it a half a liter. Because if all 1,000 is a full liter, this would be a half liter because it's got half, right? So what I want you to understand today is that depending on the size of your container, even though you have the exact same amount in both of them, it can look different depending on the size and shape of your container, okay? Look at it. Now, this one only holds 250, okay? So, 250 is half of 500. Did you know that? Okay, well, let's look at that. Okay, I'm going to pour some of my green water in here to 250. And if I pour half, should I still have 250 here? Yes, and I do. Look at these two. Do these look like they have the same amount in them? Okay, I chose this one because it's more of the triangular shape, and so it changes the shape, but the height's the same, but the shape's different. It's coming in more on these sides, okay? So this is coming up higher because this only goes to 250 milliliters, but really, they have the same amount inside of them. Do y'all see that? So I'm just really wanting you to make sure that when we get into volume a little bit more and we do some of our experiments, we have to really pay attention to the size and the shape of our container that we're using. Okay, let's see what 250 would look like in this one. So all that's measured on here are even hundreds. So we've got 200 to 300. So I would have to put it between, I would kind of have to measure it and eyeball it and say this is between 2 and 300. Still at 400. It's a little above 300, so I'm going to pour a little bit more. There it is. A little lower. Let me pour a little more. So that's between 2 and 300, about 250. And look how much, it doesn't look like much at all actually in this container, right? Because it's the largest one in size. Okay? So do you see the difference in these? Okay? And so we would measure looking at our beaker or our cylinder, whatever it is, and we would measure looking at the milliliters and then understanding that once we get 1,000 milliliters, we then can convert that to 1 liter. Does everybody see that? Okay, great job. So we're not going to have time to play this, but this is something that you can do at home. So I have a matching game here, and what I did is I put pictures. You could put words on index cards, and you could write jug of water, chicken noodle soup can, okay, honey jar, oil in a train, water in a cauldron, syrup, mustard, pool, and you play it like memory, okay? Who's ever played memory before? You try to find 2 that match, right? And you flip them over and you have to remember where they were. Well, with this one, you're not looking for a match, you're just looking for matching measurements, okay? So for example, if I flipped over the honey and the mustard, would we measure these using the same type, same unit of measure for volume? You think we would? Do you think that we would measure this in liters? Or do you think that we would measure this in milliliters? Remember, 1,000, like the weight of a pitcher full of a drink, okay, or a jug of water, that is like a liter. These are less than that, so we would measure these in milliliters. If I get a match, then I take that and I get a match. I keep these, okay? But if I get different ones, let's say that I got the mustard in the pool. Well, a pool's got a lot of water in it. I would measure that in liters, right? This one in milliliters, so I would put it back and try to find a match. So I'm trying to match the units that I would use to measure that object with. Do y'all understand that? To find the volume. Okay, so that's a fun game that you could just play at home to practice over these next couple days. You could even do that with the grams and the milligrams as well. Okay, I'm sorry, in kilograms. Okay, one last thing before we go. On Thursday, we did a lesson about time. Remember, we traveled to different countries. And so when we traveled to the different countries, we were finding out about time travel and elapsed time. And I made a mistake on the last one, so I wanted to correct that. We were counting away, and I counted 9 hours. And then when I wrote on the board, I wrote 8 hours was the time that elapsed, and then our minutes. So I just wanted to clarify that I noticed that mistake, and I'm really sorry. And so it should have been 9 hours instead of 8 hours for that elapsed time. Okay, guys, so I will see you Thursday, and we'll be doing lots more of this fun and be little scientists. So I'll see you Thursday. Bye.